Well, I'd like to thank everyone for coming out to Amuse and coming out to hear me speak. I'll just give you a quick little rundown about who I am and kind of what I do, where I'm coming from in terms of my background. I work in virtual reality. I mean, you kind of get that idea, in augmented reality for the last 15 years or so. And I'm very undisciplined, so I do a lot of different things. If you can see my title there, it says Director of Gaming Technology and Game Designer, Technical Artist, User Experience Designer. I do all those things and really enjoy it, and I kind of feel that having that kind of cross-pollination is definitely my strength. But I'm here to talk about virtual reality and augmented reality and design elements across that spectrum. So let's get started. Virtual reality. Virtual reality is at an interesting point, but it had a much earlier beginning in terms of people getting excited. And I would say that the starting point for that was in the 90s, and I call that radical VR, radical 90s VR. But it wasn't quite living up to the expectations. It was a poor response time, so when you move your head, it just wasn't updating fast enough. Limited field of view, but people were really excited about it. It also cost about $10,000 and weighed about 10 pounds on your head. And why it's exciting today is because we're at a point that I call crossing the rift. And crossing the rift, what that rift is into the consumer market. And what we have now is we have headsets that are light, they're responsive, they're on the verge of being affordable. They're technology that makes you feel that you're in a believable world. So, what about now? Where are we? Well, we're at a point where we've got over six major platforms. Those platforms are from major companies. So if you look at the companies involved and the faith that they have in the platform, that really says a lot. So those companies are Sony. They've got one for the PlayStation VR. There's Valve. They're the largest PC game distributor in the world. They've got an incredible headset out as well. You have Facebook, Samsung, Google, and now Microsoft is involved in making virtual reality headsets. So the market is at kind of that early point where it's incubating and growing. The platforms will continue to grow before they kind of narrow down into a smaller group. So the way I like to think about the market where it is today is there's a number of categories. Ignore the numbers on this slide. It's not really about the numbers or the sales. It's more about the types of VR that you can kind of design for in terms of product SKUs. So you have light VR, and light VR is what I would like to call nauseous VR. It's using devices that aren't designed for virtual reality, so like a standard Android or Apple phone, and putting it into a case. The advantage of that platform is market reach. You can reach 20 million users fairly easy. Then there's the premium mobile VR market. A little bit more exciting. You have companies like Samsung working with Oculus. And what they're doing is they're using mobile devices in combination with additional sensors to give you the minimum positive virtual reality experience. So you won't feel motion sick when you use their hardware. And then you kind of have the high end, which I would say is there's the PC market and the console market. And those numbers are probably, in reality, have been reversed this year. So there's actually, PlayStation is doing quite well with their headset. Okay, so and you can see these are the current quarter sales, bar graphs, it's all exciting stuff. It shows the potential growth of each platform. It shows which platforms are doing better than others in terms of unit sales. And it gives you an idea of kind of what you can target. And there again, more bar graphs. These bar graphs are a little bit misleading because the blue part is probably a part of the market where the experience is least desirable. But you can see that by 2020, there should be hopefully about 20 million units of quality VR headsets out there. So let's talk about augmented reality. There's what I like to call traditional mobile augmented reality, and this has been around for 12, maybe 15 years. This image that you see in the background is actually a game that I worked on about 8 years ago. It was an augmented reality treasure hunt for the AGO, which is the Art Gallery of Ontario. It was a fun project, and we did a lot of like really exciting things. One of the things that we did was we would create interactive experiences and games in the artwork. And the idea was that when you, for a gallery, one of the biggest challenges they have is actually that children hate galleries. It's actually hard to keep a child in a gallery for more than 20 minutes because the work is often more conceptual than it is visual. So you have to think about it and talk about it and all these sorts of things. It's hard to keep kids in. We created this experience where we gamified the artwork using an augmented reality layer. The use cases of this type of augmented reality, though, are fairly limited because what you need is you need to know like the context of what you're looking at before you look at it. So we had to enter in all the artwork, and we had to, it only worked when you were looking at it in certain ways. So it was a fairly limited way to do augmented reality. Now you move into more recent things, what I like to call spatial augmented reality. So this is where you're using a headset that is able to project virtual graphics into your world. It's a pretty phenomenal experience. The HoloLens has been out for a couple years now. Most people haven't tried it though, because it's a $3,000 developer device. It's not meant for the consumers. But what it does is really exciting, and it shows something that's really important, which is a radical AR innovation. I like to think of the HoloLens as the thing that they've done is they've encouraged other competitors to really like move up their game. And one of the things they did is you got to give Microsoft a lot of credit is they spent about $2 billion. And what did they do? Well, they took the research that they had from the Kinect, and then they built a custom chip. And the interesting thing, it's actually really interesting what this chip does. It's a multi-threaded DSP core. Well, what is that? It means that there's a bunch of little cores that do maybe 8 or 9 calculations. They do them really fast. They do them low power. And what does that give you? It gives you spatial awareness and spatial memory. So that means that in the HoloLens, with this type of augmented reality, if I were to place an object, right here, and I were to walk 100 feet away and I were to walk back again, it would actually be able to remember that that virtual object was still there, and it would be in exactly the same position. So the context now is really broad in terms of how you can apply augmented reality. So, like I said, Microsoft deserves a lot of credit for really kind of lighting that fire. Google and Apple have definitely felt the flames of that fire, and in the last month, in the last couple weeks actually, they've released competitors to it. They've had technology in the incubation stages. They're trying to use phones to do the similar sort of things that the HoloLens would. It's not spatial, so it's not three-dimensional in terms of you having a sense of depth to it. But what you can do is you can hold your phone up, and it does a pretty good job of having spatial memory like the HoloLens, having a sense of approximate scale. I mean, if you look at the IKEA app, I've tried it out. It's not exactly to scale. It does its best job of kind of making an approximate guess. But it's a pretty big leap for the market as a whole. And then you have some new additions, which is, I would say, it's kind of a combination. There's a company called Prism. It's pretty interesting, a product called Prism. And what they do is they allow you to use your phone in a similar way that the Google Cardboard does, where it's using the technology that Apple provides, augmented technology, and then it allows you to project it into your field of view. So you have spatial AR. It's pretty cheap compared to the HoloLens. HoloLens is, $2,000 to $3,000. This is around $200 for the developer kit. But we're still not there because that's what you've got. You've got a device that, doesn't really fit on your face in a comfortable way. The battery life is really slow. The features aren't quite there yet. So augmented reality is still a future challenge. It's quite a bit away. Because what we really want is we want a magic pair of sunglasses. We want something that is non-intrusive, that maybe can pair with another computing device that adds value and context to what you're looking at. So I'm talking about two things here. We're talking about augmented reality and virtual reality. And when I'm doing design work, when I'm creating experiences for these platforms, I like to think about two things. When I'm doing augmented reality experiences, I like to think to myself, how can I add value and context to the real world? And when I'm working in virtual reality, I like to think, how can I take someone and take their presence and put them in another world? But the truth is, even though I'm talking about them as two things, I actually don't like to think of them as two things. There's this, very academic milligrams, reality, virtuality continuum. It's not the best name, but it's a really cool concept, and it's a really cool way to start thinking about things. And if you look at it, you have the real world on one side, you have the virtual world on the other side, and then there's all kinds of spectrum in between. It's like a gradient scale. So instead of being separate categories, it's a gradient scale between the virtual and the real world. And across that, there's a common design language. And this is where I'm excited about things, and this is kind of where I want to share some of the lessons that I've learned. So, in the real world, I mean, traditionally we've had things where there's, kind of digital play spaces, we've had physical controls. It's like the example I showed you earlier from that project I worked on with the AGO. You have kind of like these see-through installations or applications that people can download. You have immersive AR, where people feel like the objects are in their world and believable. And then you have immersive VR. So what is the thing that ties, oops. There we go. What is the thing that ties the last three elements on that spectrum, which is, augmented reality through a see-through, immersive AR, and immersive VR? What ties that together? It's interactive 3D objects and worlds, and learning kind of the design language that exists across those elements. So, number one, the number one thing is presence and believability. It's the single most important thing in your experience. And from a virtual reality perspective, that means that you need to feel that those objects are things that you can touch and that you want to touch, that you want to interact with because you completely believe in them. It also means that you need to maintain synchronization with the world. So if you're talking about augmented reality, anytime you break that synchronization, you're breaking the believability in it. And then there's a number of things you can use to support it. I mean, this is traditional in a lot of different mediums, but you can use lighting, mood, and theatrics. Especially in virtual reality, it's really important to use these things to convey the story and experience that you want, because you can really control the user's emotions a lot. Haptic feedback, very handy. If you experience it in these things, when you're interacting with virtual objects, they can really help things feel more real. And at the very least, even if they don't feel more real, they feel like you're giving the user feedback, and that has a lot of value. And then sound, specifically 3D sound. If you have a headset on a user, there's all kinds of special tricks that you can do with audio to make it actually sound like something's behind you, in front of you. You know where people are looking. So it's an important layer. And from the perspective of like just making these experiences, it's amazing the value it can add and how little it costs. I find that a lot of times audio is maybe 1 to 3% of my budget, but it can really elevate an experience. So it's really important to not forget about your sound. And then one of the things that I really like to think about when I'm dealing with virtual reality specifically, but augmented reality as well, is human scale. So one of the most obvious examples is when someone puts on a VR headset, if you put them on the ledge of a cliff and they look down, they feel threatened. So depth is a really powerful tool, and you need to really think about that when you're designing experiences in virtual reality or augmented reality. But the way that it works fundamentally, in terms of how we perceive depth, is the closer something is to us, the more we assign value to it, and the more we can actually perceive that depth. And I like to think of it as the arm length is the golden rule. We measure the world in units of ourselves, so something that is 1, 2, 3 feet away has an immense amount of power, and it's incredibly believable. When things are 15 feet, 30 feet, 50 feet away, 100 feet away, you actually have a really hard time to determine the distance. It becomes a much larger scale. It's kind of an exponential drop-off in terms of your depth perception. So it's important to start thinking about how to use that as a design element. So, users, they should look around in your world. But what you're going to find is they probably won't. And I always say in design that there's a bit of a 30-30-30 rule. You have 30% of people that just figure stuff out, 30% of people that are, they can learn with a bit of help, and 30% of people that it's a much tougher journey. But where this really falls in is actually how people's vision works. And a lot of it also falls into what people's expectations are. People are really used to interacting with all the information on a screen in front of them. So people tend to look forward. And that percentage that you can guarantee is about 20%. So I like to think of that as designing for the fold. So it doesn't mean that you can't go and have content below the fold, but it just means that you have to be aware that you're going to have to really lead people to that. If you have content to your left and your right or behind you, there's a percentage of users that will never see that unless you do the work that's required to guide them to that experience. Also, when you're thinking about human scale, you have to take the limitations of field of view and you have to combine it with proximity. You need to really start thinking about how a human being would interact with things in a virtual world, as opposed to how can I have a bunch of screens. So I always like to say it's similar to designing a workspace in the real world. You need to think about things ergonomically. And to the counterpoint, if you were creating a play space, it's also similar. How would I create a play space in the real world? And then base your design based on that thought process. So stop thinking about screens, start thinking about people and how they're going to interact with it. So this is an example I like to give. Some people get motion sick from the game, but one of the things that they do a really good job of is the user interface. And they use depth in some really interesting and creative ways. So you can't really see it in this picture, but there's a circle in the middle. And one of the things that they do is it's a radar. And if the ship is behind you, it will raise or lower in three-dimensional space, and you can really see that. And if you're in a dogfight, that value is pretty incredible in that situation. So what they're doing is they're using the three-dimensional aspects of it and your ability to perceive depth and the value of that depth to give you incredibly useful information. They've created a wonderful design element out of that. They do other things too, like they put less important, they put in the first 20 degrees your field of view, they have the most important information you have. As you move out, there's secondary information. If you look to the sides, there is supporting information that you only need some of the times. And what happens is if I look to the side, I have to look at a particular point and it expands out into a much larger detail. So they've really thought the design through from the perspective of someone actually sitting in that space, but they're not limited to the physical, and they're not limited to a traditional screen space experience. So they've really done an excellent job on that. So I love this picture. This picture is something that we don't think about. We don't think about how we interact with computers. We don't think about how silly it is that we can do incredible things. We can build incredible experiences, stories, worlds, all with this little guy here, and we don't think about that. And what do we have? Well, what do we have in VR? We have a bunch of options to kind of replicate that sort of experience, and they work in different ways. We can do gamepads, and we can do obvious game-type things with them, which is fine. We can do a mouse and keyboard, which is horrible in VR. You shouldn't do that. There's some devices, and they're providing contextual controls onto the hardware themselves. You're still doing game-related things. It's okay, but it's not the best. Where it gets really interesting is once you take a traditional control of some kind, something like this in my hand, and you start tracking that in three-dimensional space. Now your controller exists in the same world as you do. It's not just an input, but it's actually something that exists in the same space as you. So the value is tremendously more. But we need to figure out how to get that mouse cursor into the world. Like, how do we project our intent? A mouse cursor is an abstract representation that we just accept because it works, and it only shows us what we need to see. Well, how do we do that? Well, there's two main things. It's raycasting and physics. So raycasting, we got a diagram here. Diagrams are kind of boring, but it's an interesting point that it illustrates. Essentially, if this was my transform, which is basically just a position and a rotation in space, I can shoot kind of like a laser pointer in most game engines. This is how they work, and this is what's called raycasting. And the computer will tell me what it hits, what it hits, what it hits, what it hits. So now I have a good way where if I'm in a three-dimensional universe, I can start interacting with anything in that universe because I can just draw a line and point a line at something and determine what the intention is. So the simplest way to do this is what a lot of people are doing on Google Cardboard, on the Gear VR, on devices where you don't necessarily have a controller. It's called gaze-based interactions. So the one thing I know the position of is your head, and I know the angle that you're looking at. So if you were to look at a button or a control or something, and if you were to look at it long enough, I could make a timer go on it, and then it would trigger an interaction. It's great when it works. It's unfortunate when you look at something and you don't mean to interact with it. So it's not a perfect system. It's not ideal. So you can take it up a level, like I said before. You could do a raycast from a handheld device, and there's for the Gear VR and the Daydream headsets, they don't do full position tracking like this, but they give you something that you can kind of rotate like that. And even that is really handy because because what you really want to do is you want to separate where you're looking and how you interact. There's a tendency that when you start doing this, that people just make screens and then you just point at them and you kind of interact with that. That's okay, but I would say that you're maybe not utilizing the medium as well as you could. And then there's virtual touch. Well, what does that really mean? What does virtual touch mean? It means that I have an idea of where your hand is. I probably have a representation of a finger or a pointing device. I know when you're in proximity of certain controls, and now you can start interacting with those controls in a more meaningful way. And there's actually a tremendous amount of value in doing it that way, because now, instead of just using the angle of something, you can really start to manipulate objects in a meaningful way. And that can be a number of things. It could be a user interface, it could be placing blocks, it could be a lot of different things. So this is an example. I like it. It's pretty cool. Just was announced a week and a bit ago. It's called Oculus Dash. It's a user interface that allows you to exist in virtual reality to access a lot of traditional computer interfaces, as well as game content and other things, and to kind of switch back and forth between these things. As someone who works in virtual reality, this is kind of a dream space. But if you look at what they've done, they've got a lot of interesting things. They've kind of designed for proximity. So it's not a bunch of screens far away. And they're using touch, and they're using a number of different inputs to create a meaningful experience where the user has a lot of control. So let's talk about physical interactions. I like this picture because it's actually from a Kinect game. And Kinect was one of the lessons I think that people really learned from Kinect was precision matters. If users try and interact with something and they don't get an immediate response every time, it's a very poor value. Other problem that we have is computers want to, with machine learning, it's getting a little bit better, but the general rule of thumb is when you're creating a system, you typically create one way for that to be, to do one thing. When users are in a virtual world, unfortunately, it's so believable that they feel that they can do things any way they want. And actually, if you give them instructions, they will intentionally try and find their own way. This happens all the time. The last one there with the hand and the fireball, that's from a game that I made where you would shoot fireballs with your hands. I would give users the instructions. I would say, punch forward and you will shoot a fireball. And people would punch forward. They would punch forward, and they would punch forward in all kinds of different ways that's not what I meant when I said it. And they were trying to be creative, because if you think about it, right? Like if I'm trying to throw a baseball, there's a lot of different ways that I could do that. So people have that freedom. So you really have to think about that when you're designing experiences, that people are going to try and throw their hardball in a weird way. This is probably a better example, and what they're doing is they're combining physical interactions with tracked controller input. So what they've done is they've constrained it. When you're using a camera-based gesture system, it's a little bit more hard to define when a user action is taking place. What this system is done, it's a pretty simple thing, bow and arrow. So they create an aiming vector between the two hands, and thank goodness there's a button that actually controls when the fire command happens. Pretty good system. So, one of the things that you have to do when you start thinking about gestures and interactions is you need to think of the best way that you can make them 100% reliable, and you need to think of ways to simplify it. Because you don't actually need to do exactly what you would do in the real world. You just need to make it so that the user's intention is always represented in the virtual world. So I always say the way to do that is to only show what's right, is to be accurate but abstract. And this is a pretty popular game in virtual reality. It's called Job Simulator. They've done a phenomenal job of experimenting and kind of creating a number of user conventions and design conventions within virtual reality that really you'll see in a lot of stuff. And you've probably seen it and never noticed it. It's actually quite interesting. And that's actually, I would say, because it's successful. So if you look at here, we've got just a floating bottle of hot sauce. The concept that the creator of this came up with is he calls it tomato presence. So that means that if I pick up a tomato, I don't actually want to think about my hand anymore. I want to think about the tomato. So the hand disappears. And there's a number of reasons why that happens. If I were to pick up an object and the hand was incredibly realistic, and I animated it in virtual reality and I represented it that way, and the way that I was going to pick something up and the way that the hand picked something up, there was a mismatch, my mind would get upset because I'm showing information that's not correct. I'm showing information that is an approximation, but it's kind of like going into the Silicon Valley. It's upsetting that that is not what I was doing. But when I actually pick up the object, so if I pick up that hot sauce, what I'm thinking about, my intention is no longer on my hand. It is on whatever I'm interacting with. And it can be picking something up, it can be controls, it can be manipulating something. It actually, if you were trying to do a physical gesture, it becomes even more important to release the visual of the hand. And one of the reasons why you do that is there's also other reasons, is that your hands are constantly linked to the real world, so they always need to be in sync. The objects that exist in the virtual world, they need to follow that rule set, and they need to stay in sync with that. So what do you do when those two things are at conflict? What do you do when the rules are being broken? So for example, if I were to take a virtual version of my hand, and I'm holding an object, and I slam it through this material, because I can do that because my hand is not in the virtual world. Well, what I would do is when this hits the surface, I would make it so that it interacts with the physical object, the virtual object. And then my hand would simply reappear, and I would break the connection between those objects. And the way that you actually hold things in virtual reality is you actually create these physical links so that you can determine and detect when they're broken. So, some examples. If you look really closely at these images, if you look at the one where the guy grabs the phone and throws the phone, you'll notice that the hand disappears. If you were playing this game, you wouldn't notice that. If I were to tell someone that that's how I was going to design the experience, they would tell me that I was wrong. But like I said, the way it works is you always focus on what you're interacting with. If you look at when the guy opens the box, his hand disappears, and his hand may have moved it really far away, right? It's actually really hard to keep yourself completely in sync with a virtual control, but you're still interacting with it, right? If I'm trying to spin a wheel, maybe my hand goes really wide on that wheel. But being able to accommodate that while representing it correctly is really important. So the brain is really happy to fill in the gaps there. Oops, wrong way. So, being abstract and being correct and only showing what's correct is even more important in social interactions. I don't know if anyone has seen any of the Facebook stuff where Mark Zuckerberg is, kind of acting stuff out in VR. It's really cool that they're trying to make a social platform for VR, but I feel that they may have gone a step too far. I had an experience a couple years ago at Oculus Connect. They had an experience called Toy Box. You stand in a virtual space. The other person that is there with you is a real person, and you're interacting with them. And the fact that it's not mimicking any of their facial expressions, it's just their head bobbing and their hands moving and their voice coming in at real time. Your brain receives that information and is 100% really, really happy to kind of fill in the blanks there. Once you start filling in that data, you get a little bit upset. And actually, when I had this experience, I felt like I knew exactly what this person was going to look like. I thought, wow, I bet you she's about this tall. She's blonde. I don't know why she's blonde. In my head, she was blonde. She's probably like a really fun person. I had a really good impression of who this person was. And she came out and she talked to me afterwards. And she was, I would say, about 90% how I had envisioned her in VR. And not showing me what she looked like gave me a better idea of what she looked like in my head. So we've got an idea of some ways that we can kind of represent things, some value that we can add in terms of how we create things. But now we also need to know what to avoid. So basically anything that breaks synchronization. So that can be a lot of things, but anything that breaks synchronization between the virtual and the real world. And this is true for both virtual reality and augmented reality. For both platforms, lag is one of the biggest ones. So if I move and things don't synchronize in time, there's going to be problems. I'm not going to believe in that experience. One of the biggest things in virtual reality that can break that connection is when you see velocity and you don't feel it. We don't really think about it, but it's actually a pretty big deal. The inner ear, don't mess with the inner ear in virtual reality. It's one of the things that you can't get around. We don't think about it, how big of a sense it is, but basically we have a gyroscope type device in our head, and it tells us where down is, and it tells us every time we change speed and direction. It's an important survival thing. And what happens in human biology, this is not, by the way, this is not a proven theory. I thought it was a proven theory, but it's not a proven theory, but it's a well-liked theory in the virtual reality community, that when there's a very strong disagreement between your senses, that you're going to want to feel like you're going to vomit. And why that is the theory is that it's a survival response, that maybe primitive man, if we had accidentally eaten a neurotoxin like a mushroom of some kind, and what we were seeing and what we were feeling were out of sync, that there would be a survival advantage to getting that out of your stomach. This is a rule you can't break, and this is why I kind of discourage Google Cardboard for any length of time longer than 2 minutes, because it doesn't meet the minimum requirement for you to not feel like that way. Like I said, I've spent 110 hours in Skyrim in VR, and I have a hard time spending 5 minutes on a Google Cardboard. So just think about that in terms of your user experience. So I've got some helpful things that will help you plan out projects. I mean, you guys all have a really strong tool set in terms of user experience design tools and processes that you follow. I have some adaptations to some basic ones, some small ones that will be really helpful. Storyboarding. We've all done it. You need to have a different flow of storyboarding when it comes to virtual reality and augmented reality, because you need to not just plan a screen, but you need to plan everywhere that they could look. You need to understand where the macular vision is going to fall and what is going to fall on the peripheral vision and what's going to be behind them, and assign value to that and plan your experience frame by frame through a storyboard to really get an idea of what the user experience is going to be. And it's a great way to share things before you invest. This is actually from a project that I worked on recently. There are tools that let you draw in 3D. So there's Quill and Tilt Brush and Medium and a bunch of tools that let you sculpt and draw using VR devices. The advantage of this is one of the things that's really hard to figure out in virtual reality is how the sense of scale is going to work on things, and how that's going to work from a pacing and a design perspective, all kinds of things. Very cheaply, if you've got someone who can illustrate or you can illustrate, you can quickly sketch out some ideas in 3D. And we did, I think we did for a project I'm working on right now with the National Film Board, I think we did about 30 to 50 panels to plan out like an 8-minute experience. And it was incredibly valuable. It let more people participate instead of just the people who have game engine experience. So it was incredibly valuable and an empowering tool set. And then live action role playing. I don't mean LARPing. You don't have to wear a costume, but you can if you want, because that's a pretty good costume. But what I do mean is that you need to have, or it would be ideal if you acted things out. And it would be ideal if you acted things out with, from a Dungeons and Dragons perspective, what would be a game master, where there's one person that you will ask questions to, and they will tell you what you see or what is happening at any particular moment. What this will do is, first of all, it's super cheap, which is great, because making content in VR is not cheap. But what it will do is you'll find all kinds of holes in your experience that you wouldn't find until much further in the pipeline, and you can do it really quickly. It's a participatory process, so you can get more people involved. People will understand what you're talking about much sooner. And like I said, you'll realize that in your experience, you may have thought that you have had it mapped out, but you'll realize there's a lot more detail in the flow. And you'll get that from the question-answer response of someone kind of controlling the world and another person existing as a user. And you can use traditional game prototyping technology. It's not much different than if you're doing a web, but the core focus is to not invest in any art. When you're creating 3D art assets, they take a long time. They take a long time to make, and they cost a lot of money. And once you've done that, you're so invested in your creation that it's really hard to pivot and change. So making your experience with the minimum requirement amount of form and the minimum requirement amount of animation, but to have the interactive flow so the user can go through it without anyone telling them what to do, is also going to add a tremendous amount of value. Because if you make that an enjoyable experience, if you make that the experience that's going to add value for your user, when you add the other layers of art and sound and lighting and dialogue and all the other things that you want to add, it's only going to be a better experience. But if you can prove that it's going to be good without those things, you're onto something. So key takeaways. Always focus on what the user's intentions are and how you can deliver that in virtual reality. Always think about your design from a human scale perspective, and always maintain that link between the virtual and the real. And also, I really would like to stress the last one, but try to think ways to add value as opposed to gimmicks. There's a lot of things that people do in virtual reality and augmented reality that I would say are very gimmicky, but how can you add value? How can you make it so that you're using augmented reality that makes the user's life better, or tells a story better, or creates an experience that's so memorable that no one will forget it? Ooh, what's going on there? Oh, thanks for coming out.
Hello, Stephan. There's some questions about, well, the first is, what do you think about Apple VR? Could it be a real game changer?
Apple VR. Well, Apple VR isn't out yet. Apple AR.
Let's talk about that.
Yeah, so I think it is a game changer. The fact that both Google and Apple are entering that market, it is a game changer. And there will be some early use cases of that. The fact that they've entered the market is the first step. I think that there's still probably a couple more generations before it really adds a lot of value.
Mm-hmm. it seems like Google Glass had many of the qualities we're looking for in AR devices today. So why did it fail?
Because it wasn't an AR device. It was a notification device. It wasn't actually contextualizing your world with meaningful value. It's the same as a smartwatch.
There are a lot of questions. I'm just combing through. What are the ethical concerns about VR and AR games with kids?
Oh, kids, there's...
Too young to...
Outside of kids, there's ethical issues. And actually, one of them is personal space. It's actually quite intense. It's really insane what people do to you in multiplayer games.
So risky place to be for a kid.
People virtually touch you.
Oh my God. Okay.
Yeah. But what's happened is this is something that's happened and people are already problem solving it, where there's constraints that stop people from doing that. So it's one of those things. Every time someone does something wrong, someone comes up with a way to stop them.
We could do a whole section on that one.
Yeah.
What do you think about, or did you think, or do you think about Pokemon Go?
I think that it was really good in terms of the awareness that it brought to AR as a platform and a technology, and the fact that it showed that you can make a successful product. So even though it had a huge spike of interest, and then maybe the value of the gameplay wasn't quite living up to the hype and it kind of fell down, you'll still see a gradual growth of the technology after that. People are excited about AR. I can't say anything better than that.
So what do you expect will be possible with this tech in 10 years? So you're at Amuse, number 13.
Yeah. Magic sunglasses, Terminator vision. I can
vision.
Google can draw a line on the floor, tell me where to go. I can get information about any product. I think like 10 years is actually a place I like talking about. Okay. I mean, that's why I'm thinking about the design elements that I'm thinking about today, because if you think about it where it's going to be 10 years from now and you learn to kind of design with that in mind, it just opens up so many doors.
For designers new to this medium, where should they start learning about the tech and user experience principles? Do you have some resources or games you'd recommend for beginners?
Games, I would really recommend Job Simulator. Oculus has some human interface guidelines. I would start reading about it.
Yeah, just sort of.
I would start going on the blogs. What I would do is, the number one thing I would do is I would get hardware. I would get hardware and I would start using virtual reality, because you'll try a good experience, you'll try a bad experience, and you'll have a good idea of what you think works and what doesn't work. But if you don't actually have access to personal hardware, it's pretty hard to do that. Even if there's company hardware, it's really hard to do that.
And what's a good entry point for someone who is inspired today and wants to go out and start doing that? What would you recommend they buy?
Depends what you have. So if you have a Samsung Galaxy 6, 7, or 8, you can get a Gear VR for $100. If you have a phone that supports Daydream, for $100, you can get a headset. If you have a PlayStation VR, for $400, you can get a headset. If you're all in, you can get an Oculus Rift or a Vive. And those are the ones that are easiest to start developing for. And if you're all in, just go for it.
Well, thank you so much, Stephan. We appreciate it.